Okay, this last screencast goes along with Module 11 Skill Builders. I don't think I actually labeled it as Skill Builder 8, but I guess that's what we could call it. So we've got a table. We have several numbers down the column: negative pi, 7, 1/4, 0, square root of 3, negative square root of 3. Across the top, we have negative pi, 7, 1/4, 0, square root of 3, and the negative square root of 3. And the table is asking you to add the two things together. So negative pi plus negative pi, that's 2 negative pi's. So that's negative 2 pi. Negative pi plus 7 is just negative pi plus 7. There's really no way you can just write and combine that. You could also say 7 minus pi or negative pi plus 7. It's the same thing. All right, so what I'm going to do is I'm going to fill in this chart. I'm going to pause, and I would encourage you to fill it in as well. Maybe use a pencil and then double check that you got what I got. And then we're going to talk about whether we have rational, irrational numbers and whatnot. Okay? Okay, so the first thing I did, and y'all know me, I pretty much color code everything. I did blue for irrational, and I did red for rational. So this is irrational, etc., that kind of thing. So go ahead and fill this in. Okay, I've got these first two columns done, and here's what I'm going to do. I'm going to take a red map pencil and I will shade anything that is rational, and then I'm going to take the blue and shade anything that's irrational. Okay, when you combine these, that is going to be irrational, so I'm going to leave that and color it blue in a minute. And all of these involve pi, and pi is irrational, so when I'm adding or subtracting with pi, that's all going to be irrational. Okay, 7 minus pi, that's irrational, but this one, 7 plus 7, that's rational, that's 14. 7 plus a fourth, that's rational, 7 1/4. 7 plus 0, that's rational also. Okay, these other ones, negative 2 times pi, that's irrational. 7 minus pi, that's going to be irrational because I can't represent these things as a ratio of two integers. Okay, all of these are going to be irrational. Okay, irrational, irrational, irrational. Okay, let me do the next couple of columns. Okay, next two columns. This one involves pi. It's going to be irrational. I can't represent that sum as a ratio of two integers. That one's also irrational. Down here, 1/4 plus the square root of 3. I can't represent as a ratio of two integers. 1/4 minus square root of 3, same thing. All of these guys are irrational. I cannot represent them as a ratio of two integers. However, all of these that I'm shading in red, those are rational numbers. Okay, let's do the next couple of columns. Okay, so I've added these two guys together. That's going to be irrational. 7 plus the square root of 3, that's irrational. 4th plus the square root of 3, that's irrational. 0 plus the square root of 3 is irrational. Square root of 3 plus the square root of 3 is 2 times the square root of 3. That's irrational. But the square root of 3 minus the square root of 3 gives us 0, and that is rational. Square root of 3 minus pi, that's irrational. Square root of 3, negative square root of 3 plus 7, or 7 minus the square root of 3, that's irrational. 1/4 minus the square root of 3, that's irrational. Negative square root of 3, that's irrational. But negative square root of 3 plus the square root of 3 is 0, and that is rational. And then negative square root of 3 and negative square root of 3, that's negative 2 times the square root of 3, that's irrational. Okay, but here's what I want you guys to notice. if I take a rational number and I add it to an irrational number, like here and here and here, 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 if I take a rational and add it to an irrational, your answer is always going to be irrational, okay? If I take a rational number and add it to another rational number, your answer is always going to be rational. However, if I take an irrational number and add it to another irrational number, sometimes you get a rational number. Like here, we said negative square root of 3 plus square root of 3, and you get 0. Okay? So I'm going to scoot this up a little bit so that you can write those 3 statements down. Okay, so we have rational added to an irrational number. Your answer is always irrational. A rational number added to another rational number, and your answer is always rational. But an irrational number added to another irrational number, sometimes it's rational, sometimes it's irrational. Okay? All right, the next table down at the bottom is a similar principle, but this time we are multiplying rather than adding. Okay? So we have the same set of numbers, it's just this time it's multiplication. Okay, let me show you what we get. All right. Negative pi times negative pi is pi squared. 7 times negative pi is negative 7 pi, etc. Okay, so take a moment and carefully put the products from each of the multiplication problems into their appropriate box. And then you'll notice that this time there are more red answers for rational than there were the first time. So blue still stands for irrational, red is rational. Okay? And here's what you get. A rational number times a rational number is always rational. A rational number times an irrational number can be either rational or irrational. So for instance, this one was 1/4 times the square root of 3, and that was irrational. But 1 over the square root of 3 times the square root of 3 really is square root of 3 over square root of 3, and that comes out to be 1. So that one, you had a rational and an irrational. Sorry, that's 2 irrationals, and that's a rational answer. Let me find one that's rational and irrational and gives you a rational answer. Rational is 0, and irrational is like square root of 3. 0 times square root of 3, that's 0, that's rational. Okay. So rational times irrational can be either. Irrational times irrational can be either also. Okay, so either rational or irrational. And remember, just irrational numbers are numbers that you cannot represent by a ratio of 2 integers or a fraction, a over b, those 2 things being integers. Okay?